Today we're going to be doing some KQL threat hunting, basically building some queries that would be super useful like in an enterprise environment. We're going to be doing 3 use cases today. We're going to do top failed login attempts. We're going to do top IPs with failed logins. Then we're going to do a brute force detection and also like a new location sign in KQL. So we're actually doing 4 KQLs. And don't worry about like all this here. I'm going to be walking you through every query step by step. So what I'm using today to be able to do this, since like the Azure lab doesn't really have sign in or authentication logs, is this website called kc7cyber.com. All you would do is go to the website, and then all you would do is here it's going to look different. I've already hit play, and then you just hit start your first investigation free. It's going to boot up. Then once it boots up, you'll have a screen like this with like the the story here and all that. You can like go through this. This is a really good website for learning KQL and how the querying works by like a game style learning. I haven't actually like done the story or anything yet. I was just like building my own queries here because they have like logs for you and stuff. So first query we're going to be doing is the top failed login attempts, right? So what we'll do is we'll just kind of follow along on this script. So in this game, sign in logs, or how they have it here. Yeah, sign in logs is actually authentication events for this game. So we just type this and hit run. We're gonna see a bunch of logs pop up. So we got the username, the result of the login attempt, the password hash, the description, IP, hostname, and timestamp. All super important information for what we're going to be doing. So this is called the data set, right? Or the log or index if you come from Splunk. It's basically like think of it as a Google sheet, right? With this information in it. So if you were to open this in like Google Sheets, you would see this exact output from there. So you would have the column names here, hostname, source, user, etc. And then you would have like filled in the row the information for each column name. So basically what we're going to be doing is querying this data set and then basically drilling down and specifying the information we want to see on the output, right? So the first one we're doing, I'm going to write this as a comment here just to keep it top of mind. Basically top failing IPs, right? So the reason why we'd want to look at this is like basically like maybe a reporting thing, or you're starting to drill down on brute force or a new location logging query. So you'd want to see like, okay, based on all the users I have, like what are the IPs that are being failed, that people are failing to log in from the most. So how do we even start to do that? Well, what we want to do is drill down the time frame we want to look at. This is good because it's going to make your query more efficient, right? If you just typed, like, if we just run this here, this is going to query every single log that we have stored. This depends on retention time as well. So, like, for example, most companies do a 90-day or 60-day or 90-day or 6-month retention period for logs. Unless they're in a heavily regulated industry like law or banking and stuff like this, then it's more like 5, 10 years just for compliance purposes. But anyways, what I'm getting at is you're going to want to query a specific part of the log of the data set so that we're getting a faster response time. So how we can do that is by using the timestamp here. And what we're going to do is type where. So where is like select if you're familiar with SQL. But basically what the where keyword does is it's saying, I want to specify this part by this, right? So what we want to do is specify the timestamp, and we want to check that the timestamp is within, we'll do 7 days just for this query, right? So it looks a little weird, but basically what this line is doing is it's only giving us logs from the last 7 days. So basically in this data set, it's going to query and look for the timestamps that match this expression here. So basically any timestamp that's within the last 7 days, it's going to display now. And then if you wanted to look at exclude all the logs from the last 7 days, you just flip this to greater. Now that we've got our time period, we've got our data set, we want to make sure we're only looking at failed logins because as you can see here, we have a mix of successful and failed. So we're just going to drill this down further by saying we're specifying result. We want to see only things that are equal to failed login. So basically, the reason how I got this name was right here. This is the result. So it depends on your logs, but sometimes you'll get like a Windows event log or a Azure event log, or you'll get text here. But for this case, we have text, so we would use a text. If it was like a Windows event log, you would do something like 4026, something like this. But for our cases, we're just using failed login. So now if we run this again, it's going to drop our results down. And now we're only getting failed logins, right? This is what we want. So now what we're going to do is create a table based on called failed logins, which is going to give us the count. And we're going to count by the source IP, username, and we'll do host name just to basically make it like kind of easy to tell. So I'm just going to double check what I already had here. So we do count by, yeah, username, IP, and location. So we actually don't have a location. But in a later query, we're going to look at how we can actually add this through a function in KQL. But basically, yeah, this is what we want to see. If we just run this real quick, it's going to give us an error because errors are cool. But let's see if we complete this, it'll still error. Okay. Yeah, so we just had to add this. So basically what this line is doing is we're ordering the output of the table and descending by the count that we get from failed logins. So as you see, click down here, the output has changed. Now we have failed logins here, hostname, username, source IP. And just to further explain this line, like the count function, what it's doing is counting every single log in there according to these three log columns. And so that gives us this basically. So the highest failing user within the last 7 days is this the laundry guy. So basically what we'd want to do like in a real live environment is like once we have this information, obviously we would be able to export it or whatever to CSV. And then as cybersecurity engineer or vulnerability or risk and compliance GRC, your job will now be to like find out why these users are failing so much. Is it like, oh, they just don't remember their password, they're bad at technology, or is there something else going on? But as you can see here, like this is an internal IP. So if I had, based on my experience, like if I had to guess, this guy is just like really bad at remembering his password. So he failed to log in a lot of times since the source IP. Now, if this was an external IP, it would be different, right? Because then it's like, okay, so many logins. This guy is like 38, which is more out of anyone here. And it's coming from an external IP. Like, is there like brute force happening to the Caesar that we need to look into, right? But there you go. You've written your first cake. Well, not if you watch my lab video, this is not your first one, but you've written this. Basically, what this does is it detects um top failing IPs by user and first name. So there you go. You can save this. This is going to work in any KQL environment. You just need to change the variable names. Like you would need to change the data set name. You need to change this. You need to change this, and this, depending on like what your data comes through as. But that's basically it. You would just need to modify that. Sweet. So let's move to the next KQL one, which is going to be top IPs with failed logins. So let me just like analyze this because it's kind of similar to like the one we just made. Okay, the difference here is we're deduping the users. All right, so I'm just gonna copy this in, and I'll go just for like time's sake. I'm copying it in, but like obviously we got to update the. All right, so the reason why before I change this, I'll explain it. So remember this one from the last one, like timestamp. We want to see like greater than the last 7 days. We want to see like basically anything that's over 7 days old, where result is not equal to zero. So sometimes Windows would just, if the login is successful, it will just say zero. If it's not, it will give you like an error code. So that's why there's a zero there. But for our case, we're looking for failed logins, right? So they just did it like opposite. You can either do like not equal to successful login, or you can just do like if it's equal to the one you want. So you do something like that. It's going to give you the same result, either one of those. Then what we're doing is creating another failed login table here with a count. And we're also adding in a deduped count for usernames, right? And we're calling it users targeted. Obviously, we've got to change this to the username because that's the data column we're getting. Then we want to um, order this or organize this by source IP and location. We don't really have location, so we'll just take that out. Actually, what we'll do is we'll add it in, right? So what we're going to do is extend. What this does is basically add another column onto the, and I'll show you guys here. I'll just take this out. It adds another column onto the data, right? So let's just run this here just so we get our log output. We get absolutely nothing because we have nothing over greater days, over 7 days old. Run it again. Now we're getting our results. So you can see here, the last one we have is description, right? So now what we're going to do is add another column, which gives us information from the IP, right? First off, this is not going to work with private IPs. So just bear that in mind because you can't really get information from threat intelligence for private IPs, but this will work for like this right here where it's a public IP. So what we want to do is extend, give it a variable name. So we'll just say country. Then it's equal to, we're going to do geo info from IP address and then slap source IP in there. Now what this is doing is it's taking the IP address, and this function, what it does is it gets the country, city, state, and I believe one other thing for the IP address. And what we want is just the country in this case. So we'll just specify the country. What this dot country is doing, right? So basically this function returns an array object of those three variables I just told you, country, city, state. How we can tap into a specific one is by doing this dot to access the object and then specifying the key value that we want, which is country in this case. So now what this is going to do, if we run this, is add another country tab here. And now we get the location of the public IP address. And the ones that are empty are private IPs, so we just won't be able to know the location. But basically, in an enterprise scenario, we know the internal IP address is coming from our network, so we don't really, well, we still care, but as it's not as likely that an attacker is brute forcing from inside unless they've already gained some type of foothold. But anyways, we're back. We're going back to what we're doing. So I'm just gonna paste in the rest of the thing that we had before. Yeah, I'm actually gonna put this before we do the country so that we're making sure we're only doing failed logins. That's crazy, dog. Okay, we're back. So some reason we're not getting any logs. Let take this. Okay, I see. So these logs don't have any failed logins from any IP that's not from internal. So what we'll do is we'll just remove this line and then we'll leave this right. So we'll just run this real quick, see what we get. We get nothing. Oh, it's this threshold we're doing here. It's too high. So 10. Yeah, that makes a lot of sense. So just, I'm adding in this line again because I want to add the country to the I want to add the country to the output. So for the public IP addresses, right? All right, so our query is now done. I'm just gonna put at the top failing like what's it called? It was top IPs that failed out of top IPs with failed logins. So the last one was like by usernames. So we're looking at the users that most frequently failed to log in. This one is specifically focusing in on IPs. And you can see here, basically this, we're getting the most failed login from 9 users from this internal source IP address. And then if we come down here, the public ones, mostly just have one user associated with them. So this is like pretty standard. Like obviously what you would do is like China is kind of suspicious, but what you would do is like go in here, and then you would want to be like, okay, like you can create another where you're like, we'll do it. So basically we're trying to figure out like who that user is that was signing in from China. We're do the first we got to like extend and do that enrichment again. Just gonna copy the line. All right, so we've added the line and then we want to project username. Oh, sorry. We want to basically make sure we're focusing in on the China. And we should only get one log in this case, but we're gonna do it like the way you should do it, not just because we know we'll only get one log. First, I'm just gonna test this to make sure it's working. Obviously, it's not working, so let's try this. Actually, we have multiple. So this is a good, good thing to see, right? So now you're actually seeing like there's a lot of, oh no, it's the same user logging in. I know we have, um, yeah, so it's multiple different users signing in. So what we'll do here is do a summarize user user login success count. We want to see by result. IP is equal to d count plus d username and host name. All right, so what I'm doing in this line is basically I'm trying to see like what users are signing in, and it's gonna be giving me the count per user and per host name with the deduped IP. So let's just like see what this gives us. All right, so yeah, you can see this helps the output a lot. So these are all the users that are logging in from China, right? And we see that the Wells is has the highest number, followed by IC Blake. So basically, that's how like the investigation flow would be, right? Like this query, you would just basically see like all IPs, and then you can look for ones that are just like sus. So basically, like India, China, Slovakia would be ones that would stand out to me, just because like most time U.S. employed users are not going to be in those countries. And then what you could do is like use this query I just whipped up here to basically like further dig into that. Then what you would do now is like basically go to your intra AD or your on-prem AD and check whether these users are actually like one part of, well, they are part of your country if they show up in these logs, but I mean company, they show up in these logs. But so you would want to check like where the user is supposed to be working from. This is going to be in the AD information or intra AD. And so if it doesn't match up with like where this IP address is logging in from, then you know that there's basically someone trying to brute force this user, right? And then if you want to like even further drill this down, what we can do is check specifically for like successful logins to see if like any of these users were compromised, right? And how you do that is like using this line here. So basically, in this data set where the result was a successful login for the user, here we're getting the country and we're making sure the country is from China. So basically, this highlighted portion is telling the query to look through authenticated events for successful logins from China. And then we're going to see how many times how many successful logins there were. So we'll run this, see what we get, and boom. So this is very, very bad. Um, if these users do not work from China, this means that basically one, two, three, four, five users were compromised if they are not supposed to be in China. So that's just like the power of KQL and how you can use it. And we're still not done. We still got two queries to go, which I have over here already written. So that was one we already did. So brute force, right? That's what we're gonna work on here. Um, Basically what this is checking for is like basically this depends on company policy too, like what the threshold for brute forcing is for you specifically. So most companies they'll do like five, because it's a good threshold to have, just because of like if someone fails five times within like a few minutes or like 30, whatever the time frame you select here. Here I have 1 hour, but like let's just say yeah, if someone's failing to log in within like over five times within 1 hour, like that's probably something you should look into. It might not be malicious, they might just be like really bad with technology, but that's basically what we're going to do. So with this query, we're looking at this threshold of five. Basically, why we're declaring this variable. So the let here is basically saying that this is a variable that we want to use in our query, and it's equal to five right now. The threshold is going to be how many times they have to have a fail, how many failed logins they have to have before this reports or alerts, because this query would be turned into an alert, right? Then what we're doing is going back to our authentications event dataset, looking for all the events under 1 hour and within the last hour, basically. And we want to make sure the result is not a successful login. So we're looking for failed logins only, which is where this line comes into play. Now, what we're doing is we're summarizing by fail count, sort of getting the count of the failed logins, and then we're organizing it by username and source IP. And then here what we're doing is checking that fail count against threshold, right? So we're here, we're saying where failed count, which this is going to be now a number of failed logins, and we're checking to see if it's greater than or equal to 5. And it's important that you put the greater than equal because if you just put greater than, then it's only going to report on failed login attempts that are greater than 6. And we want to make sure that we're looking at 5 and above. So that's why greater than equal is important. Then join this line right here is basically adding a column to this table right here. And what we're doing is basically joining in a column that's looking at the failed login. This is kind of redundant, I'm seeing now, just because like we were only looking at failed logins in the first place. So I'm gonna, all right, let's just like run this real quick to see what we get. Okay, we get that. Let's see what we get when we take this out. Oh, I see what we, okay. So it's just giving us the full logs again. Um, Instead of like just the table. Okay. So yeah, that's what this is doing is it's kind of like we're adding basically this column to the original log output. And then project is basically the project operator just shows us what we want, like columns want to see. So sometimes the logs will have like 20, 25 columns if we only want to see like specific ones, which would be like the ones we see here, which are like the most important. And then we could just drill that down to 1, 2, 3, 4, 5, 6 columns, which is way easier to look at. And we're ordering it by timestamp. So this is a good query to look for brute force events. And we can see here, it's not ordering. So actually, I would want to change this to fail count because we'd want to see the highest failing user within the last hour. So we change, now we get a better so it looks like this user is failing to log in for a bunch of different host names with all the same amount of tries. So yeah, this looks pretty suspicious for sure. So there you go. This would be an alert. How you could actually make this better is probably just remove this. Okay, I see. That's why it was failing because they wanted to add the description host name there. But we could just do like host name here. Check this out. So yeah, this is a little easier to look at than the other one because it was like going crazy. But yeah, so there you have it. Like now we would want to go start investigating this. Like why is D Wadri failing to log in 38 times within 1 hour to his computer, right? We could just say that's his computer. Want to like reach out to the user, see what's going on, that kind of stuff. All right, last query here. We're going to be detecting external authentication events and enriching the IPs with location data. So I already previewed this with you in the other queries we've worked on in this video. We're using this function for KQL to enrich the IP data. So this time what we're looking for is so this query is a little different because we're looking for external, sorry, public detecting authentication events from external IPs. So we want to look strictly for like non-private IPs. So like all the IPs that are 10 dots, like this 10.10, 05, 01, 019. Like we want to exclude those because we're strictly looking at in this query external logins. So just removing this because I was testing it. So to walk you guys through this query, obviously starting from basics, authentication events, data set. Here, what we're doing is basically making sure the source IP is not empty because this query is just gonna like error out if it's empty because of this right here. It won't take an empty IP. So we just want to make sure the query is working, always doesn't error out, doesn't crash. Then what we're gonna do with this line is check if the IP is private or not, right? So thanks to KQL for having this like already as part of the tool set. Makes it a lot easier. So we're just putting in the source IP, column name, and we're checking whether it's private, which is basically like if it's a 10 dot or a 175, stuff like this. We'll make sure this is false, right? Because we don't want private IPs. So now that we've basically stripped down our log set to only only logs that contain a source IP one and logs that do not contain a private IP. So now we're only getting logs of public IP addresses that were in our authentication data set. Now what we're doing is enriching the log to give us the country of that source IP that we're looking at. And then we're checking for a successful login. Okay? Because what we're detecting here with this query is logins from a new location. So for example, sometimes people will travel or yeah, so most common use case I've seen is like people traveling for like a work meeting or a conference or whatever it is, really like could be a lot of things. But basically the system is going to be like, oh, this person normally logs in from New York, but now they're logging in from Miami. This query would catch that. Or this person's normally logs in from the US. Well, this one's focusing on country, so it actually wouldn't catch the prior use case that I just said. But we can like make one that would look at specifically cities. But for use cases would catch would be like, oh, this user is usually logging in from the US, but now they've logged in from Europe. This would alert. So we'll continue on here. We're looking for only successful logins. And then we're building a table based on distinct IPs. And we're doing organizing that by username and country, and then ordering it by country. So if we run this, we'll get this. So it looks like United States, Taiwan. So we got 4 logins from Ju, Cole, 1 IP from Taiwan. So that might be something we want to look into. Slovakia as well, India as well, China, obviously. And well, depending on if you have people in Brazil or not. So basically the query is working as intended. Like for this use case with this query, we're basically seeing that like, oh, these people have not logged in from this country before, but they just did. So for example, let's just say Jukul, right? He's normally based in Europe, but now he has 4 logins from Taiwan. Like we would want to reach out to him and be like, hey, we want to check for like, oh, is he traveling? One, is he actually in Taiwan? If he's not, then we know that this is like basically a compromised user and we want to take action as fast as possible. Because basically this is saying that this user had successful logins from Taiwan, right? So I appreciate you guys sticking with me through this whole thing. I hope this was like really informative and helpful for you guys. Um, KQL is super useful if you can learn how to use it. Once you learn like one of these languages, query languages like KQL, or Splunk's query language, anything like that. Like all of them kind of blend together. The only thing that's different is basically like the keywords. So like these like keywords, I'm talking about like where or extend or summarize or project, stuff like this. Like those are the ones that are gonna be different depending on like the platform you're using. But once you understand like how to construct it in one platform, it's really simple. You just go to the documentation. Like I was, you saw me do it a few times here. Microsoft has it here. It could be like, oh, what does the where operator do? Like I don't remember what it does. Oh, okay. It filters a table to a subset of roles that a satisfy a predicate, right? Like, okay. So basically like this basically filters for what I'm looking for. Okay, that's helpful. Like, oh, what does geo info from IP address do? I forgot. Okay, retrieves geolocation information for IPv4, IPv4 and IPv6 databases, and it shoots me back these variables in an array. Oh, it's super helpful. Okay, yeah, cool. So that's just like basically the power of KQL. But sweet guys, next projects I have coming up are like I want to do an AI security one, which I'm going to work on next week. And and yeah, guys, keep following me for more content like this. If you guys are looking for a community of people that are trying to learn cybersecurity, trying to get into cybersecurity, or if you're already in the field and you want to network with people, other people in the field as well, join my computer community in the link below. Other than that, guys, I'll see you in the next one. Peace.